So in station 2, instead of looking at graphical representations of relationships, we're looking at tables and hoping to identify whether or not the data in those tables represents a linear relationship. So the main way we do that using a table is exploring something known as the finite differences. And as you can see in your note, the finite differences are the differences between consecutive or back-to-back values of the dependent variable in your table. So when you're finding these finite differences, you look at two consecutive values and you take the second one and subtract the first. So the finite difference for the first pair of values would be -3, 9 minus 12. We look at the next pair, and we get 6 minus 9, also -3. Look at the next pair, we get 3 minus 6, also -3. Interesting. We get the same finite difference value for each pair of consecutive values in the table. Now, if we apply this to the next table, and these tables are not the same as your examples, they're just random examples, and I'm hoping you'll be able to apply what you see here to your tables. If we look at the finite differences here, we get 4 minus 1, which is 3. Then we get 9 minus 4, which is 5. And then we get 16 minus 9, which is 7. So in the first table, the finite differences are constant. And in the second table, the finite differences are not constant. And this is a key difference between linear and nonlinear relationships when you're looking at the tables. So take a guess right now as to whether you think the constant finite differences create a linear relationship or a nonlinear relationship. And we can confirm that by graphing. So when you're graphing something, you want to pick an appropriate scale. So it looks like one step on the x-axis would work well, and perhaps steps of 3 on the y-axis would work well, just to fit with our table here. So at -1, we have a value of 12. At 0, we have 9. At 1, we have 6. At 2, we have 3. And if we connect all those dots, that was a terrible line. If we connect all those dots together, roughly, don't have a ruler, then you'll see that this would appear to be a linear relationship. So when the finite differences are constant, we get a linear relationship. When we look at the next one, here our finite differences were not constant. And again, let's look at what the visual graph would appear to do. So when here we can do, let's do 2, 4, 6, 8, 10, 12, 16. Tiny graph, but hopefully it'll work. So 1 and 1 is going to be halfway through. 2 and 4, 3 and 9 is going to be up here. 4 and 16. So these don't quite connect with a straight line. It's actually going to be a little bit curved. And so when your finite differences are not constant, you end up creating a non-linear graph. So the key thing to identify whether a relationship is linear or non-linear when you're looking at a table of values is to look for the finite differences.